Hey everyone, my name is Shankar and welcome to my YouTube channel. Today we are diving into a super important topic in database system, transaction management and concurrency control. Introduction to transaction management. If you ever wonder how database handle multiple users trying to access to modify data with the same type of time with creating a charts. The video is for you where we break down the concept simple terms, look some real world example and make sure you will walk away understanding why this stuff matters. So grab a drink, hit like button, jump into it. What is transaction? So what exactly transaction in database terms? Think of transaction as a single unit of work you need to be completed fully or not at all. It's like ordering food online. Either your entire order goes through a payment process, restaurant confirmation, delivery is arranged, or none of it's happen. In a database, or language transaction is sequence of operation performed as a single logic unit of work. For example, when you are transfer money from one bank to another, two main operation is affected. Deduct money from the first account, add money from the second account. Understanding a transaction. A transaction is a logical unit of work that executes sequence of operation as a single entity. It must be fully completed or not executed at all, ensuring that the database remains in a constant state. Key characteristics of transaction: automatically all up or nothing execute. Consistency maintaining database validity. Isolation transaction operate independently. And durability. Committed changes exist after failure. Together, these properties safeguard database integrity during constant operation. Understand ACID properties. Transaction follows what we call the ACID properties. Isn't about chemistry, is not accuracy stand for automatic transaction are all nothing, either all operations in a transaction succeed but none of them. If something fails halfway through the system, roll back how things were before the transaction started. Consistency. Transaction always move the database from one valid state to another. All rules, constraints, and triggered must be satisfied. Isolation. Even when multiple transactions are running at the same time, each transaction should be feel like it's the only one accessing the database. No, transaction should be see partial result. Another transaction. Durability. One of transaction is committed, its changes are permanent and survive the system failure, crashes, power outage. These properties are what make database reliable even the chaotic scenario with thousands of users. Concurrency control. Now here where things interesting, what happen when multiple transactions try to access the update the same data at the time without proper control. We could run into survival problem. Lost update. One transaction, one transaction overwrite another transaction change without even realizing. Dirty reads. One transaction read data that another transaction has modified but hasn't yet modified. The second transaction eventually roll back its changes. Non-repeatable reads. A transaction reads that same data twice but gets different result because another transaction modified the data between reads. Phantom reads. A transaction executes a query find new row and that were before because another transaction added them. This problem can lead data inconsistency, which is a big no know in database system. Concurrency control techniques. So how database even prevent this issue through concurrency control, locking the most common approach. When transaction need to access the data in a place, lock on the data, prevent another transaction from interfering. The shared lock for reading and exclusive lock for writing. Locking-based protocol. Locking-based protocol is a two-phase locking. To clear it's a strict variant play virtual role preventing a concurrency issue. This protocol manage access of data ensuring transactions are isolated from another. Multi concurrency control. The database keep multiple versions of data read. Don't block or write. Vice versa. PostSQLs or many modern use this approach. Isolation level. Isolation levels a dedicated towards visibility of uncommitment changes between transactions with level of dragging from read uncommitment low S and serializable highest understanding this label helps in balancing performance with data integration during concurrent transaction. A real world example in recovery management, a bank transfer. Let's see this concept in action with our bank transfer example. Imagine two transactions happening at the same time. Transaction 1, transfer 1000 from account A to account B. Transaction 2, add 50 rupees interest to account A. Without concurrency control, if they both transaction read account A balance is 1000, at the same time transaction 1 would be it 900 after deducting 100. Transaction 2 would be update 1050 after adding 50. Whichever transaction completes last win that the order changes get lost. With the proper concurrency control like locking, transaction 2 would be wait until transaction 1 finish and then work with updated balance of 900. Result is 950, the current amount. Example 2, airline reservation. Imagine the last seat of flight and two customers trying to book simultaneously. Transaction 1, customer A checks seat availability, see one seat left. Transaction 2, customer B also checks seat availability, seat 1 is left. Both decide to book a seat without concurrency control. Both might be get confirmed for the same seat with proper isolation through Outlook MBCC. Once customer A start the booking process, the seat would be temporarily locked, forcing customer B to wait, eventually see that seat is no longer. E-commerce invalid. One our last example, e-commerce. Imagine an online store with limited stock of proper items. Transaction 1, a customer place a order for last 3 units. Transaction 2, the store manager update the inventory count after finding 2 damaged units. Without proper concurrency control, the customer might be order items that aren't actually available, leading to proper customer experience. With technique like two-phase locking database would be ensure inventory update of consistent, accurate. Recovery management. Recovery management is essential for maintaining a data integrity in the event of failure. Techniques such as transaction logging, checkpoint, and rollback operations ensure the database can be restored to consistent state following crash errors. Performance consideration and best practice. Balancing isolation level and performance is a critical transaction management, optimizing transaction designing, minimizing log contention, and selecting appropriate isolation level, enhancing database throughout while maintaining reliability. And there are you have it. We have covered the essential transaction management and concurrency control. To recap, transaction and logical unit for work follow ACID property, concurrent access lead to data inconsistency problem, and database system use various techniques like locking and MVCC to prevent the issue. I hope this helps how database handle multiple user operation without falling apart. If you found helpful, please hit the like button and subscribe for more database tech content. Drop your question and comment below. And I will see you in next video. Thank you.